From April 2013 to June 2014, Tradelossa worked on a project that involved the transportation of several components from the port of Coatzacoalcos in Veracruz, a state in southeast Mexico, to Etileno 21. The most challenging item transported during this period was an ethylene reactor C2 splitter. The transportation of the cargo was, by itself, a true challenge, not only because of its dimensions, but because of the obstacles along the road. Sector: petrochemical. Cargo: ethylene reactor. Dimensions: 302 feet long by 32 feet in diameter. Weight: 1,940,067 pounds, or 970 short tons. Route: the transportation started at the port of Coatzacoalcos and had as its destination the largest petrochemical project in Latin America, called Etileno 21, a 7.5-mile trip. Physical elements. The state of Veracruz is one of the most important states in Mexico for oil and gas production, as well as petrochemical and refinery processes. The port of Coatzacoalcos is one of the main ports of import in Mexico. The location of Etileno 21 made the Pajaritos terminal the only option to handle overdimensional and super heavy pieces. However, this terminal was not suited for such a challenge. Another element in the project was that we had to move out of the port other oversized pieces, putting Tradelossa at its maximum capacity in hydraulic equipment. Safety considerations. Experienced hydraulic trailer operators, support staff, and field supervisors. Safety training. Self-done engineering analysis for multiple turning radii and a road bridge. Important civil work analysis. Permitting. Use of escort cars. Coordination with the consignee, and use of adequate safety equipment. Planning the job. Before the transport was performed, 28,800 man-hours were invested in the planning, analysis, and engineering studies to find the best transportation solution. Route. Although the road to use was not as long as usual, it had 6 major obstacles that couldn't be avoided by just using an alternate route, because in fact, there was not another route that we could use. Numerous road enhancements were made in order for the cargo to arrive at its final destination. Permits. Several types of permits had to be issued, such as 1. Port permits. 2. Private terminal access to exit the port. 3. Transportation permits. 4. Clearance and utility permits. 5. Civil works and access to Pemex facilities. 6. General civil work permits. 7. Coordination with local authorities and police escorts. Equipment configuration. One 32-axle, 6-meter-wide, self-propelled modular trailer configuration was used, as well as 2 19-axle SPMT configurations in order to cross a road bridge. The vehicular configuration was carefully designed and modified, considering the obstacles, which included turning radii, limited vertical clearance, and an overbridge needed to be crossed, forcing weight to be distributed differently. But in order to get to the installation point, the short configuration was not suitable. Engineering drawings, vehicular configuration options, and a proposed execution plan were presented to the customer for its final approval. Execution. Man-hours, 3,000. Before the transportation took place, important enhancements were made to the road. The civil works were performed by a specialized engineering company, which required simultaneous coordination with the customer and Tradelossa. This joint effort provided the road conditions necessary for the transportation to be perfectly executed. There was limited time to complete the project. Therefore, the cargo had to be taken out of the port and the transportation begun as soon as the civil works were finished and the corresponding authorities issued the permits. This meant that time was another obstacle to defeat. Obstacle number 1. The first challenge to overcome was exiting the port terminal through a private facility yard, which first had to be adapted for us to use. At this point, the road to exit the port was not suitable for the cargo. The width and turning radii made it impossible. The Agronitrogenados yard was an abandoned plant and our only way out. A road had to be built within its premises in order to meet turning radii of the splitter, and solid enough to hold the weight of the cargo and the equipment together. It had wider lanes and a new turn specially made for the configuration to have a less challenging radii and to be able to perform maneuvers. The turn was also modified so negative camber wouldn't be a factor that could impact the distribution of the weight in the transportation. The slopes were tested because the slightest miscalculation would have caused significant damage to the project. This decision also helped the road offer maximum load stability, since in a certain way the path was specifically designed for this piece, an achievement which in some projects would have been only considered a dream. If the 19-axle configuration with hydraulic trailers on the ends of the splitter would have been used on this new road, it would have been impossible to make the sharp turn. One of the vehicular configurations considered for the project was adding turntables. However, this was not the most feasible solution. If the turntables were used outside the port, the next obstacle on the trip would have been harder to overcome and delayed the cargo to its destination. Obstacle number 2. Once outside Agronitrogenados, a pipe rack with 34.4 feet or 10.5 meters of vertical clearance had to be crossed under. The authorities demanded a 1.67-foot, 50-centimeter security gap between the cargo and the pipe rack. This meant that the vehicular configuration and the cargo had to be 34.4 feet, 10.5 meters high. Discarding the use of turntables was vital in order to overcome this obstacle. If the engineering department would have chosen them, the height of the cargo plus the vehicular configuration would have been 40 feet, 12 meters, meaning that the pipe rack was not going to be cleared. The height of the pipe rack was not enough for the cargo to pass under. Once again, civil works were required. Engineering analysis dictated a unanimous solution. The reactor could not avoid this obstacle by passing on one side of the rack. The rack crosses and covers the area, and the only way was to go under it, through the previously built road. Therefore, it was decided to increase the height between the floor and the pipe rack by digging the ground 6.6 feet, or 2 meters deep, to obtain the desired height, including the safety gap between the load and the pipe rack as requested. Engineering calculations and the action of modifying the road were made 6 months before the transportation of the C2 splitter began. With the approval of the customer and the authorities, the adjustments were made. The road was modified, the slopes were tested, the width of the road was adjusted, and the height under the pipe rack was increased. Before the improvement was made, the vertical clearance under the pipe rack was 34.4 feet, and after the dig-out, the clearance was 36 feet, providing significant difference. At the time the transportation was being made, this obstacle was with no doubt an easier challenge to overcome. Obstacle number 3. Once we joined the main route, we had to skip a roundabout through the right, maneuvering due to the length of the splitter. After we crossed the pipe rack, we continued along the dirt road that was improved and widened for us to place the other components that were taken out of the port before the splitter. These components needed to be stored since the splitter was to be delivered first. Safety precautions were taken when the components were placed along the route, since they were not meant to be an obstacle for either regular traffic or the C2 splitter. At the end of the dirt road, and in order to join the main street which would take us to the project site, we had to circle a roundabout. Due to the fact that the piece was too long, we had to maneuver back and forth to turn right and join the street. Local authorities assisted us with traffic control. power line and telephone clearances had to be removed, and a safety barrier with pilot cars was created in order to signal our way through. Obstacle number 4. On the 5th mile of our journey, a road bridge needed to be reinforced. During the survey and engineering analysis that was performed, it was agreed that the bridge was not able to handle the vehicular configuration weight together with the piece without reinforcement. The customer, along with authorities, began working on arrangements months before the move, and all the civil works were concluded just a week before the C2 splitter actually went over the bridge. Even though the bridge was reinforced completely to support the loaded 32-axle configuration weight without making additional changes, the authorities demanded us to shift to a longer configuration so it could distribute weight in a more efficient way and prevent any further damage. We went from a 32-axle 6-meter wide SPMT to a 2 19-axle 6-meter wide SPMT. In order to change from one configuration to another, the splitter had to be placed down over beams and stools in a designated area along the road. By breaking up the configuration, the weight was distributed on both ends, and the bridge carried only half of the cargo's weight. This adjustment took the field crew 3 days, which is a short time considering that other components were transported at the same time as the steel giant. Once the bridge was crossed, the 32-axle configuration was placed back in the same exact position. Then the authorities gave us the okay to continue. Obstacle number 5. A second line of pipe racks remained ahead of us. This time the clearance was 36.7 feet. During the reconfiguration, before crossing the bridge, we managed to change lanes in order to avoid the lowest side of the racks driving against the traffic. As mentioned before, the use of a 32-axle configuration was crucial in the success of the transportation. If turntables would have been used, the height of the cargo would have been 38 feet, and impossible to cross even on the highest side. Although this obstacle did not require any civil works or road adjustments as the first pipe rack, we were able to cross this obstacle with special safety measures to stabilize the cargo. The road slope was also an element that needed to be carefully revised. Obstacle number 6. Continuing to drive against the traffic, we encountered our final challenge: crossing Route 180, one of the busiest routes in the industrial side of the city. With the help of local authorities, escort cars, and our crew, we were able to sign, block, and stop traffic on both lanes of this access road for almost an hour. Finally, as the last feet of the piece entered the access road to Etileno 21, and C2 splitter reached its final destination before the eyes of thousands of witnesses, a new conquest for the heavy haul industry in Mexico was attained, and Tradelossa set the standard. Conclusions. Planning man-hours, 28,800 hours. Execution man-hours, 3,000 hours. Total man-hours, 31,800 hours. Equipment used: one 32-axle 6-meter wide SPMT hydraulic trailer configuration and two 19-axle SPMT hydraulic trailer configurations. Distance traveled, 7.5 miles. Transit time, 20 days in total. Transportation cost, significantly reduced by using the same type of equipment, even though different configurations were employed. 0 incidents, 0 accidents, and no damage to the cargo. Dare for new solutions.